So this is Chapter 3, Section 1, Lines and Angles. We're going to start with a warm-up. So these are all ideas and words that we learned in Chapter 1, and a lot of these terms will show up again in Chapter 3. So let's start with number 1. Points that lie in the same plane. If we have points that lie in the same plane, those points would be coplanar. Two angles whose sum is 180, so two angles that add to 180 would be supplementary angles. The intersection of two distinct intersecting lines. So we have two lines that intersect. These two lines would intersect at a point. So number 3 would just be point. A pair of adjacent angles whose non-common sides are opposite rays. So remember, we have opposite rays, or rays that point in opposite directions and form a straight line. So if we have a pair of adjacent angles, so we have one angle and two angles, whose non-common sides are opposite rays, so that's where we have this line. This would be a linear pair, because we're talking about the pair of angles and they're on a line, so they're a linear pair. So the objective of 3.1 is to identify parallel, perpendicular, and skew lines, and to identify the angles formed by two lines and a transversal. So the vocab in this section is parallel lines, perpendicular lines, skew lines, parallel planes, transversal, corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. So we're going to go over all of those words in this section. So first, let's take a look at parallel lines. Parallel lines, it's indicated by the symbol, and they are coplanar and do not intersect. So when I think of parallel lines, I think of railroad tracks. So you have two lines that will never intersect, and they are coplanar. So in this figure, we have line AB is parallel to line EF. So if you look at the picture, it's indicated by these arrows. So when you see the arrows, you know that these two lines are parallel to each other. Again, we have two arrows here, so the lines with two arrows are parallel to lines with two arrows. So we have EG is parallel to HF. So that's parallel lines. Next we have perpendicular lines, which is indicated by the symbol. They intersect at 90-degree angles. So in the figure, we have line AB is perpendicular to line AE. So remember, we know that these boxes indicate that this is a 90-degree angle. So when we're looking for perpendicular lines, it's important that we look for these boxes to know that AE is perpendicular to AB. And again, we see another box down here. So we know that line EG is perpendicular to line GH. Next, we have skew lines, which are not coplanar, and they are not parallel, and they do not intersect. So when you think of skew lines have nothing to do with each other. They're not in the same plane, they're never going to touch each other, and they're not parallel. So in this picture, we have line AB and line EG. These two lines are in different planes, and they will never intersect, and they are not parallel. And lastly, we have parallel planes, which are planes that do not intersect. So just like we have parallel lines, these are the same thing, but planes. So in this picture, we have plane ABE, which is talking about the top plane, is parallel to plane CDG, which is talking about the bottom plane. So if you think about a classroom, you have the ceiling and the floor, and those two will never touch each other. So the ceiling and the floor would be parallel planes. segments or rays are parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. So if I have two lines that are parallel, the segments within those two lines, so if I had a segment here that is just part of the line and a segment here that's just part of the line, so the segments within those two lines would be parallel as well. Okay, so now we're going to look at our first example. Identify each of the following. So identify a pair of parallel segments. Remember we said parallel segments are identified by the arrows here. So we know that segment NK is parallel to segment ML. So here we have segment NK is parallel to ML. And then we would put a segment on top of both of those to indicate that we're talking about the segments. So identify a pair of skew segments. We know skew segments are going to be in different planes and they'll never intersect. So we have segment SN and KL. Those are in different planes, so they're not going to intersect. So SN and KL. We have to put the segment on top because we're talking about segments. Next, identify a pair of perpendicular segments. So we look for this little box here to show that those are 90 degrees. So we know SN is perpendicular to SR. So we could write segment SN is perpendicular to segment SR. And lastly, we have a pair of parallel planes. So we could say that the top card and the bottom card are parallel. So we have plane NKL is parallel to plane SRP. We identify a plane by 3 points in the plane that are not on the same line. So we could pick any, when talking about the bottom plane, we could pick any of these 3 points, any 3 out of the 4 points to name this plane. Identify a pair of parallel segments. William. BE and CD. Perfect. So we would write BE with the segment is parallel to CD. What about a pair of skew segments? Remember, skew segments are not parallel and they never intersect. Sarah? FJ and GH, those would be parallel.
DH.
Oh, DH. DH, perfect. So we have segment FJ and segment DH. Now, what's a pair of perpendicular segments? Yes. FJ and EJ. Perfect. So segment FJ is perpendicular to segment EJ. And what's a pair of parallel planes?
BCD, FJD.
So BCD, talking about the top one. Yes. And what was the second one you said?
FJH.
FJH, talking about the bottom. So BCD is parallel to FJH. Now we're talking about planes, so we wouldn't put this segment on top.
You put anything?
You could write plane BCD and plane FJH. Now we're going to talk about angle pairs formed by a transversal. So a transversal is a line that intersects two coplanar lines at two different points. The transversal T and the other two lines R and S form 8 angles. So if we look at this picture, this line T would be our transversal because it cuts these two lines at two different points. So this point and this point. Everything on the inside of these two lines is the interior. Everything on the outside of the two lines is the exterior. So we have corresponding angles which lie on the same side of the transversal and on the same sides of lines R and S. So here we have angle 1 and angle 5. They both lie on the left side of the transversal, and they are both on the top. One's on the top of R and one's on the top of S. So these would be corresponding angles. What would be another set of corresponding angles here? William?
2 and 6.
2 and 6. Because they both lie on the right of the transversal, and they're both on top. One's on top of R and one's on top of S. So we have angle 2 and angle 6 are also corresponding angles. Now we have alternate interior angles, which are non-adjacent angles that lie on opposite sides of the transversal T between lines R and S. So interior, meaning that they're going to lie on the inside in this red part, and alternate, which means that one will be on the left side of the transversal and one will be on the right. So here it says we have 3 and 6 are alternate interior angles. What's another pair of alternate interior angles? Ryan?
4 and 5.
4 and 5. Because they're on different sides of the transversal and they're on the interior. So we have angle 4 and angle 5. Now we have alternate exterior angles, meaning that they're on the exterior. So they're going to be outside of the two lines. And they are opposite of the transversal. So one's going to be on the left, one's going to be on the right. So this says we have 1 and 8 are alternate exterior angles. What's another pair of alternate exterior angles? 2 and 7. Now lastly, we have same side interior angles. So interior, meaning that they're going to be on the inside, and same side, so they'll be on the same side of the transversal. So they are consecutive interior angles that lie on the same side of transversal T between lines R and S. So this says we have 3 and 5. What's another pair of same side interior angles, William? 4 and 6. So we have 3 and 5 and angle 4 and angle 6. Now we're going to look at some examples. So give an example of each pair. So we have what are corresponding angles? First of all, what's our transversal? Yes.
The line in the middle.
The line in the middle that goes up and down. So this one is our transversal. Now what are corresponding angles? William.
Angles that are on the same side but on different,
So same side of the transversal.
but different. One's on the exterior, one's on the interior.
Right. So what would be an example?
2 and 6.
2 and 6. So we have 2 and 6 are corresponding angles. What are two angles that are alternate interior angles? William.
3 and 6.
Alternate interior. So they're
3 and 5.
3 and 5. So they have to be on different sides of the transversal, but they're both on the interior. So we have angle 3 and angle 5. What are two examples of alternate exterior angles? One and 7. So alternate meaning that they're on opposite sides of the transversal and they're both on the exterior. So angle 1 and angle 7. Now it's an example of same side interior angles. Ryan.
6 and 4.
Same side interior, so they're on the same side of the
4 and 5.
4 and 5. Yep. So you have angle 4 and angle 5. Let's look at their example. What's our transversal in this one? Francisco.
Line, horizontal.
The horizontal line. What are two corresponding angles? William.
1 and 3. Oh wait.
1 and 3. Yep. Angle 1 and angle 3. What are two alternate interior angles? Francisca.
2 and 7. Oh no. Yeah.
2 and 7. So they're both on the interior and they're on opposite sides of the transversal. So angle 2 and angle 7. What are two alternate exterior angles? 5 and 4. Angle 5 and angle 4. And lastly, what are two same side interior angles? Francisca. 2 and 3. To determine which line is the transversal for a given angle pair, locate the line that connects the vertices. So identify the transversal and classify each angle pair. So we have angle 1 and angle 3. So which line would be the transversal? So we're looking at 2 and 3.
Wait, no, 1 and 3.
Oh, 1 and 3. 1 and 3. Which line would be the transversal?
2 and 5.
We're looking at a line. So remember, we have lines L, M, and N. Those are our 3 lines we have here.
Oh, yeah. So, N.
If we had line N has nothing to do with this angle. So we need a line that's involved in both of the angles. Alex, what's our transversal? Line L, N, or M? Line L. Because it's touching both of these angles. It's touching 1 and it's touching 3. So if line L is our transversal, what are angle 1 and angle 3? Corresponding angles. Because they're both on the same side of the transversal and one's on the outside and one's on the inside. Now let's look at angle 2 and angle 6. What would be our transversal? Line N. So N is our transversal. And then what's the relationship between angle 2 and angle 6?
Alternate exterior.
I think she knows it.
So they're on the interior, and they're on opposite sides of the transversal. Yeah.
6 is not interior though.
If we're looking at, so these are our two lines. We have this line, and our transversal is line N. So this would be the interior, and this is the exterior. So what's the relationship between 2 and 6? 2 and 6. Bella.
Yeah. And are they corresponding? Because it would be the same number.
William, do you know? So they're on opposite sides of the transversal, and they're both on the interior.
Interior.
Alternate interior.
What's the like over?
N, because N was the transversal. So we're naming the transversal and the relationship.
So like 1 and 3,
So for 1 and 3,
it was
the transversal is L. It can't be M because M is nowhere near angle 1. It can't be, oops.
But what was the corresponding angle for the first one? 'Cause I didn't-
So what's your question?
What the heck?
What time does this class end? Time flies when you're having fun. So what was your question?
I don't understand the corresponding angles.
Okay, so corresponding angles. If we have two lines, I'm going to draw it down here. Two lines and a transversal. So corresponding angles are going to be on the same side of the...
I know what they are, but I don't know what they are on like this
So
triangle thing.
for 1, we have angle 1 and angle 3. So this is our transversal, because the transversal goes through the two angles we're talking about. So this is one line that we have, and this is the other. So corresponding angles are going to be on the same side of the transversal. So both of these are on the bottom of the transversal, and they're going to be on the same side of the line that they're on. So they're both on the left side of the line. So one's on the exterior, one's on the interior.
And then what they mean to like classify each angle, like what do we do?
That's what like those two angles would be corresponding angles. We're classifying them as corresponding angles. So now we have 4 and 6. So angle 4, where's angle 4 and angle 6.
Where is the exterior and interior for N?
Well, what's our transversal here? M. So this line is our transversal, and then these two lines are the lines that it intersects with. So this would be the interior, and this would be the exterior. So if we have 4 and 6, what are they both on the interior or exterior? Exterior. So what are they? Alternate exterior angles. So identify the transversal and classify the angle pair, angle 2 and angle 5 in the diagram. So we're looking at 2 and 5. What would be our transversal, William?
Line N.
Line N. So our transversal is N. And then how would we classify these two angles?
Same side interior.
Same side interior. Perfect. So identify each of the following. What is a pair of parallel segments? Yes.
LEKF.
LE and what else?
KF.
So segment LE is parallel to KF. Massimo, what's a pair of skew segments? So remember, skew segments are not parallel and they don't intersect. Francisco, what are two skew segments?
DC and BF.
DC and BF. So we have segment DC and segment BF. What is a pair of perpendicular segments? William.
DC, CB.
DC and CB. So DC is perpendicular to CB. And what is a pair of parallel planes? William, this one. HGF. So we're talking about the bottom one. Is parallel to plane. What was the second one? DCB. The top one. Last slide. What is one pair of alternate interior angles?
Isn't it not like the diagram? Isn't it not
Name an angle here. What's one angle? What do we have to name an angle by? If
ABC.
ABC, right, that's an angle. So we would call it ABC. But let's look at the bottom part here. We have two lines. And what would be our transversal? I what?
IJ.
IJ. So IJ would be our transversal. So here, what would be a pair of alternate interior angles?
H and
So you're talking about this one here, right?
Mm-hmm.
And which else? This one?
Mm-hmm. But that one's in our name, that's why.
What?
That one is in our letters.
Well, you just said we name an angle like this. Angle L, H, G.
And then it would be IGF, right?
So, and angle I, G, F.
Oh, that makes sense.
So what is a pair of corresponding angles?
So it would be
You want to come up to the board and point it,
yeah.
and then we can name it together?
Wait. Actually, I don't know. I'm not sure.
Maybe I and A.
'Cause I keep on thinking
So-
of, like I and then.
So I, so this one,
Mm-hmm.
and which one?
Wait. Corresponding with that is like.
So corresponding, so they're on the same side of the transversal, and they're going to
So it
be
would be I and HGF, right?
HGF, so this one.
Yeah.
So we have angle, this would be I,
That's not what I didn't understand.
IHE. So we're talking about this angle here. And angle
HGF.
HGF.
Perfect. Now what is one pair of alternate exterior angles?
Would that be IHE and KGJ?
So IHE, this one, and KGJ, this one. Perfect. So angle IHE and angle KGJ. Last one. What's one pair of same side interior angles? LHG and HGK. Perfect. So angle LHG and angle KGH.